Number 6 out of section 5.4, the fundamental theorem of calculus out of Thomas's calculus textbook. We have a definite integral here, so we're going to evaluate the integral at the upper limit and subtract the integral evaluated at the lower limit to get the value of this definite integral. So first thing we need to do is integrate x to the 3/2 with respect to x. So we're going to go up by a power of 1. So we go up by power 1, 3/2 plus 1 is like 3/2 plus 2 over 2. So we get x to the 5/2 over the new power, so over 5/2, and we'll clean that up in a second. Evaluated from 0 to 5, and then that equals bringing that fraction up and multiplying by the reciprocal and saying 2/5 times x to the 5/2 evaluated from 0 to 5. And so now we're going to evaluate at 5. So we have 2 over 5 times 5 to the 5/2 minus, and eventually you'll probably stop doing this step because you'll just see the result immediately. Plus 0 to the 5/2. So 2/5 times 0 to the 5/2, 0 to the 5/2 is 0. So that's actually not going to, we just need to evaluate this. So we have 2/5 raised to times 5 to the 5/2. So I'm going to write that as 2, because this is going to make this a little easier to evaluate, times 5 to the 5/2 over 5. Well, we have like bases in this case, so we can simplify. So we have 2, subtract the exponents when we divide, so we have 5/2 minus 1 is 5 to the 3/2, and 5 to the 3/2 is, you can see it, that doesn't, I'm going to put a little dot right there, 2 times 5 to the 3/2. Maybe it's easier to see it this way, but you actually have the square root of 5 cubed, and so if you have 5 cubed, there's a 5 squared times 5 in there, so you can bring out a 5 and say that that's 2 times 5 times the square root of 5, and of course 2 times 5 is 10, and that just cleans it up and makes it kind of pretty. So that's it.